Hello everyone, welcome to my channel Journey with Some. Today I'm going to talk about how we can write if-else statement in a conditional basis based on different type of scenarios in Python. Before going into it, today I'm going to execute my Python code in a visual code. If you can see the Explorer, you can click on this. You can see various types of files are existing in my programs, and you can, in the search box, you can see what kind of search you would like to give, kind of words you want to do. And coming to this branch type of symbol, it tells you your git. In the next video I will talk more about the git. As I already explained in the previous session about the git, I'll talk how we can integrate here in your visual code. This run and debug option plays a vital role in your development workflow, because when you execute your program, you can inspect where the program script is worked properly or where it failed. You can easily figure it out and fix the issues very quickly over here. So this is the prominent option in your IDEs. Coming to the extensions, so if you can type like installed, it will give you the list of installed packages which already installed in your visual code. If you want to install more, you can give the package name and you can install it. And this is the one, like the testing part, you can use different type of test. You can execute here and configure. Now we can write the if else statement for a different kind of scenarios. Now suppose you want to see whether your age is eligible to vote in your country. So let's assume the age can be like 18 in India, and we will see whether we are eligible to vote. So we'll give age which is greater than or equal to 18, and we give a condition called print, and we write it like you are eligible to vote, and we write one more condition like else statement which is false, and we write a print you're not eligible. So let's execute. Before executing, so I would like to touch upon, I want to execute this particular script in a Jupyter cell book. So I write a like some kind of symbols like a hashtag and give a percentage. It will give you a cell view over here. So where you can execute your each cell based on each code. So now shift enter, so it will execute. And if you see the interactive mode, uh, it's like works like a log or a console for your particular programming, and you can see you're eligible to vote. And we can write some more functions. Now I have given if else statement. Now we can try with if else if. We can write a multiple conditions over here. Now we can see if else if statement again. We can write multiple if statements over here. So let's try. Now assume a score which is 90, and we can see what kind of grades in a class we can get it. Now we write a condition called if score is greater than or equal to 90, and we get a grade A. And we can write one more condition by using else if, and we can score like greater than or equal to 80, and we give a print option called grade B. And likewise we can give a number of if else if statement based on your scenario you're going through. And let's assume, and we give a print option called grade see. And finally, we conclude that if not cap any of the scenario, we can print, we can grade them as like F. So let's execute now. So it will execute all your codes now. And if you can see in the first condition, it was running this one. So it will tell you that you're eligible to vote. And now as a score is like 90 now, and it was running the first execution of your statement. So based on your the value, it will try to check each scenario, and it will give you the right condition what it has to print. So in that way, you can use if else, if more than, if you want to write more conditions, you can use the else if. So in this way, you can use many more options in your data frame too. Now we can learn about some good functions where we can use this kind of if-else functions easily in your data frame. Now I will talk about NumPy where function, which will help you to easily give good kind of conditional statement. Before we running it, we import the NumPy file as np. So let's execute. So now it is imported the NumPy package, and now what we can do, we can import the pandas package to read the file, and we execute again. It's already executed if you see in interactive mode. And now I would like to read one of the file df underscore par, and it's a parquet file. If you see the type of file name is, and this is the columns what we have: id, gender, age, and country. So now we can categorize the age group into different kind of categories. So let's go to the visual code now, and we can read the file. And we are giving a data frame df underscore data equal to, so we are calling the parquet file. So we are using the pandas package pd, and we read the file called parquet, and just close it and go to the file explorer and right click on it and copy the path and just place over here, and just change the forward slash into forward slash. Now it's changed. And before we changing here, we have to give a condition called engine because it's a parquet file. So we read the engine like by arrow, which helps you to read all the parquet type of files. So when I execute it, it is telling you that some issue over here. If you see missing optional dependency by arrow is required to parquet support. So it is giving you also a condition like use the pip or conda to install pyarrow. So let's install now. Pip install pyarrow, and we execute this. It's getting downloaded. Once it downloaded, we can execute this program again. So whenever we install it, it's good habit to restart. So it will give you the new version of all the packages which is installed in your environment. So when you shift enter, so it is reading your parquet file over here. So let's wait for this one till it read. And before reading it, so I'll show you how the port files are also executed. And if you see the Jupyter window, you can see age as an integer and score as an integer. Now df underscore data, which is a data frame which has been read from outside. And if you see here, it is telling you that it is not supporting, so it is asking me to install over here. So when you install, it will help you to read your data frames easily accessible. Once it is done, just click on mark done, and now just execute again. So now you can see the data frame, So it is read your data frame over here, and it is beautifully read here. And this is your female, the gender column, ID column, age column. So now we can categorize your age group over here. Categorize the age group now from within the same data frame. So we write df underscore data, and we write the new column name, age group, age underscore group, and call the numpy package with where function, and call the df underscore data and what kind of a column you would like to check. And we are checking the age which is less than or greater than or equal to 18. We are teaching them these are like adults, and which are not, we considering them as a children. So now when you execute it, you can see a different age group called uh, age group. And it's also telling you that if you see here, none of the age group in this data frame which is less than 18. So it was given a condition called all the values as adults. If it is less than 18, maybe it would have given us a children. So this is how we can execute the different type of conditional based functions here. We can learn about the apply function now. This is a beautiful function where we can transform your data frame conditionally, and really it will helpful in an easy way of writing your functional base of statements. Now we can write one series here, and we write use the pandas and the series, and when we enter this, we have called a series has been given, so it is telling you that 1 2 3 4. Now we go to the code, and we can count with each series using this apply function, and we can give one dfa data series, and we call the series dot apply, and we write the lambda function here, and we are writing the column. So here the column is your series, and it is taking you this x1, and we are multiplying with 2. So it will give you the different series values. And if you open this one, it is also multiplied like 1 into 2, 2 into 2 is 4, and 3 into 2 is 6. So in this way, it has been calculated in an easy format. So now we can go to some more complicated conditional based function using this apply. Apply function can also be used the row wise and the column wise calculation too. So I will teach you how we can do, and we are writing a data frame called df, and when you execute it, it's creating a maths column here and science column. So let's execute this one. When you open the df, it is creating a maths row and a science row. So now what we have to do, we are calculating the row wise calculation. Now we can calculate the average of this both columns, maths with science, for each row. So how we can do that using an apply function. Now we can write a df, and we are writing column name called average and giving the data frame called df, and we are writing the apply function and open the brackets and write the lambda function, and we want to calculate the average with row wise. So we are giving a row and giving a semicolon, and we are open the parenthesis and row with what is your column name, maths plus row with science. Once you are done, divide by 2, and we are calculating with axis is equal to 1. So it will tell you to calculate of each column wise with the row. So when you execute this, and when you refresh your data here, so you can see a new column called average. So you're calculating each column wife of the average. So 90 plus 80 by 2, which gives you 85, in the same way for the rest of the columns. So this is how we can use this apply function more efficiently in your programming. So you can use this kind of functions variously based on the calculations or based on the conditional base you want to write a new columns. You can use this efficiently. Thanks for watching.